Okay, hello everybody. Good morning, good afternoon, good evening. Happy Thursday and welcome to NetBrain 201. In this class, we're going to take our first steps into being NetBrain power users and learn about parser files and runbook templates. So the way these classes work is they start with me telling you what I'm going to tell you with a PowerPoint slide deck, and then I'm going to go ahead and show you stuff hands-on in the NetBrain Thin client. As we go along, if you have any questions whatsoever about what we're discussing, please let me know right away. And you can do that either in the chat function on the Zoom bridge, or you can just unmute yourselves and ask verbally. Remember, the whole point of doing this live is for you to ask questions, so please don't be shy. The class lab environment is still very much available, and there is a workbook for this class, which can be accessed either through the files section in the class lab or in the class listing in NetBrain University. So I am operating on the assumption that everyone here has attended NetBrain 101, and so therefore I'm going to assume you all know how to access the class lab. If anyone is having problems or needs a reminder or whatever, just let me know after class and happily gesundheit. And we will absolutely go through that. So in NetBrain 101, we covered a little bit the continuous automation workflow, the idea that at its full extent, if we need to get it that far, a NetBrain deployment forms a positive feedback loop, a circular workflow, where the automation that we build can be triggered externally by third-party systems, can be triggered internally by timers or conditions within NetBrain, or can be triggered manually by human beings. And our focus in NetBrain 101 was interactive automation, just using NetBrain as needed. Now, we're going to, as power users, not just be using automation, but we're going to learn how to build our own automation at a basic level, which honestly is 90-some% of anything you'd ever need. So remember, after we have used NetBrain automation to pull and process data and so forth, find the root cause of our problem, and then made any changes needed to remediate that problem, this is when we would want to codify and create automation. So this is when we're going to create automation either to do the same thing we just did more quickly and more easily the next time and possibly allow other people to do it as well. Or if we already have existing automation, we would check it over to make sure that it's still optimal and adjust, update, optimize it if necessary. So when we're talking about being a power user, there's 6 basic skill sets that we're talking about. You can see them listed here. So in this particular class, we're going to focus on these 2. So first of all, parser files. A parser file is the foundation of all of our interactive automation. All automation that we build in NetBrain, whether it's a network intent, a data view template, or a QApp, all of them are built on parser files. So what is a parser file? A parser is a specialized file type within NetBrain that says for this output of this data source, first of all, here's how you retrieve that data source. So what's the syntax of the show command, or what's the API call, things like that. And then once you've got it back, it's our instructions to NetBrain as to how to actually break this output apart into its individual variables, the data that we're actually going to be using. And the idea is you have, and I'm going to repeat this a lot because it's a very important point, you have one parser file per output per operating system. And that's across our entire team, our entire organization, ideally, not just for individuals. So everyone's working off, for example, to take one of the show commands we're actually going to parse in today's live examples. For show interface for Cisco iOS, for example, we have one parser file that the whole team works on. For iOS XR show interface, we have one parser file. For Juniper, so the equivalent show command, one parser file, and so forth. And the idea is, as we create these things, what we're doing is we're creating, the term I like to use is we're creating a data buffet. If you think about it in terms of a buffet of food, we're cooking new dishes, preparing new ingredients, and putting them out on the buffet counter. And the nice thing is parser files, unlike food, don't go bad, so they kind of stay there forever. And so the work in this sense is front-loaded. We tend to be building a lot of these things as we're starting our organization's journey with NetBrain, but the more we build, the less we have to build over time. And it eventually becomes rarer and rarer to have to build a new parser file. So it snowballs very quickly in that respect. And then anytime we want to build adaptive automation, we just go down the line and say, okay, I want these variables from this show command, these variables from this show command, and pick and choose and go ahead and build your automation. So that's the idea of what these things are at a conceptual level. Any questions about the theory before we start to get into the practice? All right.
Nope.
So in a more mechanical level, what we're doing in the parser files is we're creating a series of expressions. Each expression contains both keywords or anchor text, as I think of it, and one or more variable statements. And what we're doing is we're giving NetBrain a pattern to look for within the output, and it will match it will find the first match that it can within the output to this pattern. So keywords are text within the output that is not going to change. And when I say that, it's not going to change between one iteration of the output and the next, and it's also not going to change between one device and the next of the same operating system, of course. So that's the pattern that NetBrain's going to be looking for. And then the variable statements are for things that are going to change. The variables, the key is in the name, they vary. And so $ indicates the name of a variable, and then we give it a name. The variables can be named anything you want as long as there's no space in it and as long as the name is unique within the parser file. So we see an example here. If the typical line of an output reads, the interface value is however many bytes, the keywords are, on the one hand, the interface value is, and then bytes, and then in between there's interface value. So whatever's between this phrase and this phrase, that is the value of interface underscore value. Okay. So that's the idea behind parsing, essentially. I should mention that all of this is based on Python, and if you happen to know Python regular expressions and so forth, you can absolutely use them in here. But if you're like me and you think Python is something you see in the zoo, then you'll be just fine. Okay. All right. So there's a couple different types of variables that are supported. The default type, so if we just have a $ and a variable name, that is what's called a simple string. A simple string, well, strings in general contain text, so they can contain any standard ASCII characters, but on the other hand, they can't be used for any calculations except for things like contains, does not contain, equals, does not equal, that sort of thing. They can't be used for math. It doesn't matter if it'll only ever contain numbers. If it's defined as a string type variable, it cannot be used for mathematical operations. So there's simple strings and then there's multi-strings. A multi-string may contain spaces, a simple string may not. So to make it a multi-string, it's mstring : and then the variable name. So which one we use will basically depend on what it is that we want to do. We're determining the behavior that the parser is going to engage in. So use whatever's appropriate. Now, if we do want to be able to do math, there's two different types of number variables. So there's an integer, int : and that's a positive or negative number without any decimal point. And then there's a float. which is a positive or negative number that may have a decimal point. So that's float colon variable name. Depending on your version of NetBrain, the interface